Google Earth Engine webinar series is conducted by Geobhoomi team. I'm the instructor, Mohammad Mafaz. I'm a former government surveyor as well as a GIS analyst. As for the beginning, we just asked what is the we are going to plan today. We'll welcome you all, and Google Earth Engine will give a basic understanding of what is Google Earth Engine and how it's powerful in especially in remote sensing analysis. And we walk through that navigation, the GUI code editor and the interface of it, and we'll do a small hands-on demonstration, and we find some application. Already I have shared some of the applications as well, and I'll explain to you what is the full webinar series is about. And finally, we have a small question and answer session. Here, whenever you have any questions, you can put it into the chat. We will answer the questions at the end of the session. So what is Google Earth Engine? It's a pretty much a cloud-based system. You have all data. It's a petabyte of data. You have Landsat, you have Sentinel, and all MODIS, and many other data. Not only the remote sensing data. You have, for example, you have open building footprint is available. You have open surface water and many other data. Who has done many research on Google Earth Engine. They have their data stored on this cloud-based platform, and it's very easy scripting. It has two APIs, JavaScript and Python API. Here we consider Java, which is the most advanced one. Advanced means it has most documented and complete version of it. Python API is somewhat good, but it's still in the developing stage. We have diverse application on it. We'll go through the diverse application on that, and what you have and where we go from that, we discuss next. So now we look into the Google Earth Engine. Why Google Earth Engine stand out? You have free access to massive satellite archives. In traditional GIS environment, you have to download the data set. It's a very tedious process. If you have worked on satellite images, you need to give a lot of time for that. And as well as you need much of the time in processing, and the processing power of Google Earth Engine, it's unimaginable. If you haven't worked on Google cloud environment, you can understand how powerful is it and how fast and how accurately you can process the data. But when you do it in your computer, PC, or how the spec is, it doesn't matter. Even when you are doing digital image processing, especially remote sensing, it takes much of time. I have worked in many of the cases. Some of the time I have to put the processing part in the morning. I have to collect the results in the evening or next day. So that much of time it takes when it's considered if the study area is huge or district wise, or you have to have many very powerful data, and it takes a lot of time. So the speed and efficiency, as I said to you before, it's very fast. It runs on Google servers. You know how big Google is and the server size of the Google is. It provides all those capacity and all those computation power for your particular project. And in traditional GIS environment, it's slow. It's very slow, and it's processing. Coding interfaces, you have flexible APIs, you have JavaScript, Python. You can customize for your requirement. Don't worry about when it comes to coding. You don't need to code everything. It is already there on the documentations and all over the internet. You just need to copy and paste. You just need to change small study area. We'll talk about those things in the future slides. And when it comes to traditional way, it is robust. For example, if you take ArcGIS, you can only use maximum likelihood classification for supervised classification in land use land cover analysis. You don't have any other sophisticated algorithms. You can't run those algorithms. To run those algorithms, first they don't have that algorithm in ArcGIS installed on that. Here you have many algorithms, most trending and most useful algorithms, which is available, freely available. And one of the most thing is the cost and ease of share. It is very much a free, 100% free. You don't need to pay anything. You can use their cloud-based application as well without any payment if you are a researcher or a non-profit organization, or you can also use for a non-commercial users. And you know what is happening most of the time. You are using ArcGIS, and you know what is the case on that. And we are using ERDAS as well. Those are very expensive softwares. You don't need for Google Earth Engine. When you are a student, you are a researcher, you are a non-profit work, you don't need to pay anything. It's completely free, and you have a lot of access on that. Storage, you have cloud, endless of cloud storage. You need very large disk space. In traditional way, you need your computer. You know how much of the computer space is needed for this processing part, and just to save it. Updates, it always updates. You have the always latest data set. You don't need to download. It's there in your fingertips, and you can always just script it and get it done. And you have a very huge community. You have very huge supporting stuff. You have a lot of tutorials. You have many documentation. It's very nicely documented, and you can use on these things in your analysis. You can not only if you are thinking about using it commercially, you have to pay it, but you can use it in a nice way. You can access high resolution data if you're going further. I'm just talking about open source way and free data sources. So why every GIS and remote sensing analyst should learn GI? It is cloud-based and scalable. You know that now the technology is towards cloud, and it's very much very scalable. You can do analyze massive amount of data. If you have proper algorithm, if you have proper methodology, you can apply those things to those methodology, and you can get it done very quickly. It's very fast and very real time. For example, we did a demonstration. We did a consultation part for a PhD student. For explaining to him, if you're doing it a traditional software in GIS environment, it might have taken us more than 1 year. But after planning all those things, it took only just 1 week or 2 weeks to complete the entire process, complete the entire work within this. I have some of the data to share with you, application to share with you. I'll share with you the things. And you have machine learning coding already. Algorithms are already predefined. You just need to call them. That's all. You have support vector machine. You have random forest. Nothing like maximum likelihood classification. The latest papers are more recommended in support vector machine classification, random forest. Those are just supervised classification algorithms. You can change all those things according to a requirement. You'll get a better output from that. And you don't have any cost. You just need the browser and internet connection. That's all. You can do the code. You can use the data and get your output. The next thing is, in high demand, you need, if you are remote sensing or geospatial analyst, in future or now itself, you need to know Google Earth Engine. GI skill is a must. Then only you will be able to perform your analysis according to industrial standard and industrial's requirement. It needs fast and reliable data. The GI is the future of geospatial analysis. Knowing GI means we talk about Google Earth Engine, short form of Google Earth Engine. We say as GI. GI makes you more than 10 times. I had mentioned 10 times more competitive in the geospatial job market. Top universities and researchers instituted worldwide, including Google, they're using this Google Earth Engine for their research, climate, environment, agriculture, urban, name it, disaster. So be in the real world. You can monitor forest in a remote sensing aspect. I'll explain to you this is forest. You have urban expansion, you have agriculture crop monitoring, and specifically disaster management. And you can use it for many GIS applications. I have shared you some of the application with you all. We'll check those application in one of the fields. I'll share with you now. Here, can you all see this? Okay, I think you can see it. Here, so here I have shown you, this is the application. You have the link is given to you. If you click that application, click the link, you will be able to see this is a flood inundation in Gampaha district, DS division in Gampaha district. Here you have 2017 flood, 2018 flood. This analysis completely done on synthetic aperture radar SAR. You have the data you can choose in your, as you can see, you just need to click and you will be able to get the output. You don't need any hard copy, or just you can share this for as an interactive map in your research or in your any other studies on your projects. You can have this like this. And another application I can show it to you. A data source downloaded from Google Earth Engine, the building footprint. Some of us need the building footprint data in our analysis. How it is shown here. You'll be able to see and this building footprint data and download it. This used in application as well. And so this is another application we have used in our analysis. This is where we have calculated the country extent using Sentinel images, calculating around 272 Sentinel images and analyzing on the Google Earth Engine. This was only possible because we used Google Earth Engine. If we didn't use it, we won't be able to do this analysis. This is a nice application. It's generated from Google Earth Engine. This is a GIS application. Badagama area to analyze the flood effect with the water level of, I think there is Ginganga, I think Ginganga. If you enter the water level, that's as I'll mention it for, you will generate the flood risk map. It will generate the flood risk. There's no they're showing there's a minor flood. Okay, here if you have the database on the people around here, it's entered, it will show who are in the flood risk zone. I'll put around 7. It will show the area where it's flooded. This is a GIS application. Here you can see these people is in danger in the flood zone. This is also created through Google Earth Engine. Very simple process. You don't need a very hard coding. You just need to apply it and get it done. You will have the application here. You can see the area as well. Automatically, you can change whether it is a satellite background. You can change it in the satellite base map, or you can use it as a normal road map. Another application. And also, I will like to share you with this one. This is world. I have extracted a data set from world open surface water. This is the entire water within the Sri Lankan Sri Lankan extent. You will be able to see all the water and their occurrence. Red is low, and the blue is higher amount of blue it's a permanent water. You can see it's around here. This is another analysis. I can keep on showing you many analyses on this Google Earth Engine. Okay, these are some of the analysis what you can have it. I'll share you the details of it. Some of the links you will be able to see and generate. And another important application is that a GIS based application. This application was it's an award winning application which was received from second place in ACRS. So I'll show you. It's a school located application generated from developed from Google Earth Engine. You have to enter your location and you have to select your whether you need to your boy or girl, and you have to select the language and select the district, whether it's done only for Western Province. I'll select Colombo, and you'll find schools on that. It'll show all the available schools in this district. Please click the district. It'll give you a buffer and distance to your place, and it'll generate within the buffer how many schools are available. So this is what is required for grade 1 admission. Grade 1 admission with according to the circular. This was a award-winning application in ACRS conference recently hit, I think, last year. So these are much more applications available, freely available. You also can check the Google Earth Engine. Here, if you go for Google Earth, just type Google Earth Engine on Google and you can go to the dataset. You have many. If you go for case studies, you have many applications. How they have used. They have global forest monitoring, and plenty of analysis. These are if you think it is very difficult, no, it's very easy to analyze because everything is given. Even the code is given for you all to analysis. In your analysis, you can use them in your analysis as well. So these are some of the applications in Google Earth Engine. And so how you can start the Google Earth Engine? First, you have to go and mostly you should have a Google Gmail. First, it's a must. You should have a Gmail account, a Google account, Gmail account. Then only you will be able to access this. You go for earthengine.google.com and you have to sign up. They'll ask some of the questions. Definitely, you have to give research and education. So those are the two the freely available. Then you will be able to access those two those Google Earth Engine facilities. And you sometimes you have to say to get approved to 1 to 2 days. Mostly you'll get a chance to get it done before 1 day. And please keep that in your mind. You have to give research and education purpose only. Don't give any other things. You just give research and education, then it will be free. And you can access the Google Earth Engine with this Google Earth Engine code editor, and you can explore the Google Earth Engine interface. So this is the Google Earth Engine interface. So you have some of the, I'll do it in hands-on demonstration to explain you all the most important part of the this. So here, what our company is about, we do in-depth course in geospatial analysis. We'll do consultancy services, and we do GIS and remote sensing analysis. We do surveying, precision land construction surveying. We'll do training and workshops on open source GIS training, remote sensing training, surveying camps, and construction driven technology with different affiliated programs. So in open source GIS, we are starting the Google Earth Engine webinar series. Then we have our services. We do geospatial research support for academics and projects and professionals. And we do private training, particularly for government organization as well as GIS. Whoever needs GIS open source or any Google Earth Engine support as well as commercial GIS will give their support training staff. And we create a particularly GIS-based environment projects for their requirement. Okay, now let's go to the hands-on demonstration. If you have a Google Earth Engine or previously created, you can go through with me. I'll do it very slowly. You will be able to understand this. Here you just type Google Earth Engine. This is the website. It's pretty much easy. First, you have to sign in. Then you will be able to access all these features. Here we will first go for the data set. You have here lot of freely available data sets. You have surface temperature, climate, you have atmosphere, you have weather, and mostly you have all the Landsat data from 1972 up to date. And you have Sentinel data as well. So here the Sentinel data is available from 2015. These are the Landsat and Sentinel data are mostly used in the research programs and researchers. And you also have other, you can check it, you have high resolution imagery. It is limited in as for free, but you have other data you can use in your studies and your analysis. Not only studies, you can use this for a professional analysis as well. So here we go back for Google Earth Engine. Then the next part is, the most important part is, under platform, you can go for code editor. This is the main part of our Google Earth Engine analysis. You can use any of the data with small code, then you will be able to do all the analysis. As I showed you here, you have the script over here. You can select the script. You have docs, you have documentation from here. This part, this is the part you will write your script. You have the canvas. Whatever you write, it will be visualized when you run on this part. So this way, you can visualize it. You have an inspector here. And you have the console. We'll check all those things with a small exercise. In Google Earth Engine, if you go back for dataset, I'm showing you an easy way to do your small analysis. For example, if you're doing a research, you have to download the dataset on your particular study area. To download those datasets, you have to go through the satellite, go through this site, other sites. For example, you have to go USGS for Landsat, you have to Copernicus Hub, you have to go for Sentinel, and you have to download the complete data. We'll go for Sentinel. We select Sentinel for the study. In here, we have Sentinel-1, which is a SAR images, and we have Sentinel-2 multispectral, we have Sentinel-3 and Sentinel-4 as well. We use Sentinel-2 multispectral data, which is the optical remote sensing data. It will have from, we have 2015 onwards. In this Sentinel-2 data, we use, they have surface reflectance and top of atmospheric reflectance. We will discuss in a future series what is this 2 it's about. Now at this moment, we will take surface reflectance data and we'll click on that. It will give us all the data sets available in to a processing level. Here you have the bands and explain the bands. You have band 1, 2, and what are these bands about? You have blue, green, and you just go through the bands. Here you have all the details. So here you don't need to think about much of the coding. You have the Earth Engine snippet. Earth Engine snippet is given. Just need to click this button or link. It will automatically give the code for the required area. So it is all the this part, you don't need to touch this at all. This is the part it use for the cloud masking part, and you also have the data set and the details of the data set. Here you have increase the size of it bit. Here you have data set details. It has the Copernicus. You have just to change the date range. These two date ranges are the one you need to in your analysis. Here you can choose the images with the required cloud percentage. 20 is the cloud percentage, and rest of the keep it as it is. Here you have the map center, and you will add. This is the location where your screen will zoom into. We'll run the data, run the script. It will run and it will show you the data set which is given to your according to this. The area which is shown here, this is the coordinate. According to this coordinate, the area is shown. So we will change into location in Sri Lanka. So what we had to do is, previously we have loaded some of the study areas from a shapefile. We can load those shapefile. We will look this in detail in the sessions, upcoming sessions. I'll just show you with the loaded data. We'll use some of the data. We'll use somewhere in Battala. I have a data source from Battala. We can import from this arrow. If you click it, it will be imported over here as table. It is the outer boundary of the dataset study area. What we can do is, we can remove this part, delete this part, and we just need to add map, and you just press control button and space button. It will automatically give all the available data sources. I'm using map.center object. It will center to the object what we are going to list out. So here we have named this study area as table. We can give any name for this study area. Over here it says table. We can change it for any area. So we just keep the table there, and we go down. And this here we gave same table. Okay, then we can just run it and see. Zoom up to the area, and it'll show you the area with the cloud percentage. It's shown the cloud area. You can change the cloud area according to your requirement. Here in the sense, I will increase the time period. I'll give it as from 2018, and I will reduce the cloud percentage. No, I'll keep it as 20. Reduce, we can reduce up to 10. So if we run again, this will be visualized. In between this area, it will show. So it just show the cloud area. I will explain in a future series how to get rid of these clouds and get a nice analysis. So in this case, you just need to change the date source, and you can change the cloud percentage as well until you get a good visualization. This data is still not downloaded. You can download your data in your area, study area. So what we're going to do, we are only going to download it to our study area. So what we are going to do is, here we have dataset.mean. We're going to take it out. We can write it as is. we can define another way, which is give dataset, the same dataset here. Mean, and we are going to clip it to our study area. Just press clip and space, give the, again, we are going to clip to a study area. It's table. We are going to add the same layer as dataset over here. That's all, nothing else. So if you run it, you will get only the area according to our study. So that's it. So you have the study area. This is our study area. You'll get it, get according to it. And now what we need, we can do further analysis on this, or you need, if you need this is to be extracted, don't need to worry. You go for your, I have given you the script. You just need to copy and paste. So I'll show you the, you have this in your slide. I copy this. As I explained to you before, these are the two things which we are going to do. We are going to mean it and we are going to clip it. These are the two code we applied, and we copy this rest of the code. This rest of the code, export to Google Drive. We copy that. And we're going to paste the same thing in the code. So we pasted code here. Here we're having the same thing. We have the data set over here. We're going to have the data set here. We're going to save the data set over here. That's all. You just need to run it again. You just expand this thing. You have the task over here. So data sets is here. You just need to run. Click the run. It will be saved in your Google Drive. I'm going to give a date training. I will give 7:30. Run. The data set will be automatically run on this. It will be exported to the data, to the Google Drive. It'll take, see, it's running here over here. You can see it will keep on running. It won't take that much of time. It depends on your speed of your internet connection. From this, you will be able to download the data. This is a small analysis. Similarly, you can do many analysis. I will, until it runs, I'll show you a few of the analysis. So here you have Hambantota land use land cover analysis. So it is not that much hard. You have all the things are defined. Here you have given the Hambantota area. Same script can be run. Just need to change the, here I have choose Hambantota. I have renamed the table as Hambantota. I'm going to give Hambantota the same thing. So the similar thing, the code will be similar. Only the thing is you have to select, change these training samples, and we have used many of the algorithms. Those are all similar. You don't need to change this at all. It's very much easy to change rest of the things. We will discuss these things in our future sessions. And we have here, this is the way to download. You have that download. It's in, I think, in a different country. Here you will be able to download. Google Earth engine build open building layer. You can download all the building layers in your analysis in future, in your requirement. We check your task, it's still running. So this way you can run. It's the script is written to download the data. So here the data set what you are given, it's already downloaded. If we go click it, go to the data source, we are opening in Drive. So it is downloaded over here. We'll check the here it's on the training data set. Data sets given. It's in training 730. You can download the data. It's just 11 MB. If you do this in your session, you will be able to, if you have downloaded, you have to download more than like 1 GB. Some of the time 1 GB. Mostly it's around 900 MB. You have to do it. You can download this thing. That's all. You just need to download this. It will automatically download to your user time. It's been downloaded. 59 seconds. Until that, I'll show the rest of the details for you all. So this thing you can download your analysis in Google Earth Engine. You can download the data sets and you will be able to get the building footprint from this one. So this is I showed you before the bumper flood. Another thing is here we have done an analysis on mangrove. I'll show how it's downloaded. I'll import the downloaded data once. So that you will be able to see downloaded data like this. A small adjustment is needed to visualize it. The band combination we have to go through. You can remember the band combination. Just put we can change the bands. All the bands are available here. So you can change even the bands, whatever you need to download it, or just if you need all the bands, you can have the bands over here. So what we have to do is we have to do it a stretch. We'll give a histogram equalizer. Apply it. Here, see, because of the cloud, you are getting like this. You'll be able to download the data. That's it. It took just less than 1 minute because of the internet connection. I'm sharing info, many other details as well, many of the area, many other platform as well. So that's the reason it gets stuck. Then you will be able to do it in just not even in 1 minute. I would say you can do it in 2 minutes and download the data for a particular year or a particular period. You can do this. You can run run on this and get it done. Not only that, you will be able to share this. Okay, so these are the script we used in this small analysis. These are the 2 scripts. Rest of the things are already there. You will be able to get it. If you have that, if you have saved your data and you will be able to share to others, I can share it to you. You need to have a Google Earth Engine account. That's all. So beyond this basics, what's next? We'll do in the lecture series, we'll do supervised classification, we'll do zonal statistics, we'll do time series analysis, we do exporting results, and each time we have a practical community support and practical exercise to support your data set. And we will cover normal NDVI, NDWI, normal algorithms, and how to create. If you have time with that, if you are efficient with, we'll show you how to create a GI app as well. So if you have any questions regarding these things what we discussed, you can put those things on the chat. And you need if you need any further clarification, you can now put the question. I'll give you 5 minutes. You can if you have any questions, you can put on this chat. continue the lecture. So I have saved the code previously we have done, and I'll share with you the link. This way, if you have a Google Earth Engine account, you have just need to click this link, and it's automatically get to the link, and you will be able to run this code easily. So this is the next part. Here this is our next Google Earth Engine complete webinar series. We have 3 weeks. First, we have in first week we'll do the introduction and visualization land set. We'll do import, filtering dataset. Week 2, we use NDVI, NDW, and change detection in disaster mapping, and as well as land use, land cover classification. In week 3, we'll do classification and we'll do accuracy assessment. At the end of week 3, we will use synthetic capture data SAR, how to import SAR and how to work on that and get that output up to getting an output and downloading the data. And the final day, we'll do a hands-on session on real world practical exercise, given a question for you all, and you will do and we will support the data sets. And we will limited amount of students for the analysis, because we'll do a hands-on session for every analysis. And we start on Wednesday, coming week on 16. All the lectures will be around 8 p.m. We keep 2 lectures per week from Wednesday to Saturday, on Wednesday and Saturday on 8 to 9:30. If you have any changes, it can be arranged. Duration 3 weeks, and we're having a live session in Zoom. So these are the things we do. If you are willing to register, you can register to this webinar series through. I'll share you the registration form. Whoever haven't registered, you can register on this. Added the registration link. If you go to the link, you'll be able to click the link and register yourself. And if you are an undergraduate students, the charges will be 4,800. If you are professional or any other academic process, you have to pay 9,800 as a fee, and you will have a lifetime support on Google Earth. You will have a community on your. If you need any, if you are available to join as a group, there are separate packages as well. So if you have anything to clarify, you can clarify with us. And thank you for listening. I can have another 1 or 2 minutes. Yeah, if you have any other questions, or you can about the course, you can ask any questions as well. And if you want to register, you can register to this link I have put onto the chat. Thank you for joining us. If you have any clarification to that be done, you can have you have the number. You can contact the number and check with our hotline. Thank you very much. Have a good night. Thank you.